All right, so now we're going to try to do this, and we're going to evaluate these. So remember that 16 to the 3 over 2, remember that that is the same as the second root of 16 cubed. Okay? So then, now I'm writing it in the radical form because it'll help me to actually, because we're going to have to do this, we're going to end up with a number. And I think our answer is going to be 64. But there's a process to find it. And we have to represent it in both the rational exponent form. So remember that 4 squared is equal to 16. So that's actually equal to the square root or second root of 4 squared raised to the third power. So I'm substituting in 4 squared for 16. Okay? Does that make sense? So then the next step is to convert it back to rational exponents, right? We said that's the same as 4 raised to the 2 over 2, but now we're going to raise that to the third power. Well, that's the same as 4 to the first power cubed. Now, what's the rule with these two numbers? What am I supposed to do with these two numbers here, up here, the 1 and the 3? You guys remember when you raise a power to a power, you let's go back and look at our notes. It's okay if you don't know it off the top of your head. Oh, it's on the other notes, I think. It's on the notes from the previous section. That's okay. But you raise a power to a power. You multiply. Okay? And if you weren't sure, like if you don't remember the rule, and remember I said that you guys will guess the wrong rule sometimes. What does this mean? Well, it really means what you should be thinking in your head. 4 to the first power is just 4 to the third power, which is 4 times 4 times 4. But also 3 times 1 is 3, so this whole thing becomes 4 to the third power. And then at that point, if you plug it in your fancy calculator, and I say 4 raised to the third power, it's going to be 64. Okay? Now you might say to yourself, Mr. Adams, couldn't we have just done that quicker the other way? No. Because the test is going to ask you 2 questions. Okay? One, and I'll show you what it's going to ask you. It's going to want you to set it up this way. It's also going to ask you to set it up. It's also going to ask you to kind of set it up this way. Ultimately, you have to reduce it down to this way. Why does it keep changing the thing? And then lastly, it's going to ask you to find the final answer. So there's really 2 different ways. It's the setup. What we're going to ask you to set it up this way. We're going to ask you to set it up this way, which reduces down to this way regardless. And this is the actual answer. Now, one last thing we could check is we could just plug this into our graphing or our fancy calculator. So I could say 16 raised to the 2/3 2 divided by 3. Oh no, it was 3 halves, wasn't it? And I still should get 64. So remember, you start off with whatever they give you, plug it in the calculator, and then start off with that last step, and they should be the same number. If not, you made a mistake somewhere. Okay? All right. Let's do this last one here. Now, this next one that we're doing, this 32 raised to the, and I'm going to zoom in. Well, I can't actually. Raised to the negative 3 over 5. Now, I need to convert that to a positive. Okay? I need to convert that to a positive. In fact, let me write this in one color so you can see what we're doing. So I'm going to say 32 raised to the negative 3/5. Well, here's the rule that we're going to use. This is the same as this. And then we're going to do all of our work just like, well, really, we're going to go through this whole process. We have a negative exponent. How do we make it positive? Well, the shortcut is you toss it on the other side of a fraction. So when I put 32 on the bottom here, this becomes positive 3/5. We don't like to do the work with negative numbers, okay? And now we do all this work, but it's under the 1. So we're going to say in the next step, this is the same as the 5th root of 32 raised to the 3rd. So it's 1 over all this work here on the bottom. Well, does anybody know of a number that when you raise it to the 5th power it equals 32? That's okay. If you don't know, what you do is you just start doing 5th roots or 5th powers in your calculator. So I say 2 raised to the 5th power. Hey, we got lucky. The very first one we tried. Now, if it didn't work out, then you would do 3 raised to the 5th, and then you would do 4 raised to the 5th, 625, or that's the next one is, anyways, I forget, I get confused. But our first one worked out, but this is how you find out which 5th power might work, okay? But we got lucky and it worked on the first one. You start with 2 to the 5th power, 3 to the 5th power, 4 to the 5th power, and you keep going till you either get to the halfway point or sometimes you can get to the actual number. So we rewrite this as the 5th root of 2 to the 5th because we know that 2 raised to the 5th power, which is 2 times 2 times 2 times 2 times 2. If you multiply those out, this is 4. These are 4. And then you're stuck with a 2 here. 4 times 4 is 16. 16 times 2 is 32. So we can rewrite it like that. And then this is raised to the 3rd power. Next way we can write it is 2 to the 5 over 5 to the 3rd power. That reduces down to 1 over 2 to the 3rd power. Anybody in here off the top of their head know what 2 to the 3rd power is? 8. And that is actually our final answer. And so this is probably the hardest thing that we're going to do with some of these properties. The negative exponents, you just got to toss those down to the bottom of a fraction. And at some point, we're going to give you some negative exponents in the bottom of the fraction, and guess what you do to make them positive? You just toss them to the top of the fraction. Okay. Any questions on this? Okay, good.